Look at you surprised. So stupid.
You do need your own calculator for the PSAT. They said you can go to the mini center and check one out. Yeah, like, so there's a rule. The people administering the PSAT, they cannot give you the calculators when you come into the room. I don't know, cause like you're taking the PSAT at a private school, and I'm giving everyone an expensive graphic calculator. I'm taking the PSAT at a public school, and everyone's getting a basic calculator. I don't know. It's something like that, right? Something about equality. So bring your own calculator. Now, if you need one, go to the media center and check out a calculator. I think they have them there for you. No, they made the rules so that certain kids didn't have an advantage, is what I'm saying. No where in the nation can walk into the PSAT site and be good at a calculator. They have to come with their own. So you can use like the fanciest of calculators on the SAT.
Does it give you answers?
If you know how to use it, it does. But you don't just wake up knowing how to use, like, it's called an Inspire. It's like the fanciest current calculator. It's like a little computer. And it takes, like, a lot of training to know how to use it. There's like a whole skill set in that. There's no certain No. The SAT is, like, very general when it comes to calculator, yeah.
Do you know how to use one of those calculators?
Yeah, I know pretty good.
Like I want to teach.
Yeah, pretty good. I mean, if you want to just get a regular graphing calculator, I can show you how to program formulas into it. Show you how to graph and connect graphs to tables. Your calculator for ACE Math, well, you can put an equation and it pops up the whole table for you, so you have all the points to graph. They do a lot that we actually don't even tell you about. The $25 calculator. Alright, so grouping for everybody who was not here yesterday. These problems are very specific. There's 1, 2, 3, 4 terms in them. 4-term problems. So when you have a 4-term problem, you have this option for factoring. You can try to put them in groups of 2. So when I see it, I don't see the whole thing. I look at the first 2 as a group, and I look at the second 2 as a group, and then take out a greatest common factor. So now we're factoring by GCF. Greatest common factor. These both divide by 2, and they both have x. So I take out the 2x and then I divide it. 10 divided by 2 is 5. I had x squared, I put x out front, 1 x left. 14 divided by 2 is 7. I had an x, I put it out front, done. You got that? Everybody got that? Do you remember how to take your GCF out? Like, what do these both divide by? 3. This is a little tip. I don't really think I emphasized enough yesterday. If both terms are negative, take a negative GCF. So instead of 3, since these are both negative, I'm going to put a negative 3 out front. They also both have y. Yeah, you can also put a y. They also both have y. 15 divided by 3 is 5 with an x. 21 divided by 3 is 7. And the great thing about factoring by grouping is you always have this moment that you know you've done it right. If you've done it right, the parentheses match. That has to happen. Doesn't match, go back, redo it. Your last step will be to write the matching step 1 and to bring in the GCFs into one group. That was here, that was here. So this is your factored form of that 4-term problem. If you were to FOIL it, you would get what you started with.
Is that what you do every time? Just you get the two things to the left. And would it ever be negative 3y? Oh yeah.
Okay, do it again. Does anybody need me to zoom? Group 1, the GCF. All right. Here's your answers for 2. Any questions on 2? Isabel, did you do 3 yet? Kind of an important part of 3. Group these. Group these. Look and see what they can multiply by. They multiply by 3 and y squared. Giving y minus 4. This is the important part. If there's no GCF, you have to put a 1 in front. If you don't put the 1 in front, you won't be able to factor correctly. Because you would just have 3y squared. And when you distribute, you wouldn't end up with a 4-term problem. Alright, if there are any questions, let's just look at your worksheet. Let's just see your worksheet answers. I wrote the answers out pretty quickly. Oh my gosh, the last 4 you're gonna have to redo, I think.
No.
Alright, here's number 5.
You need to work. Okay, let's see.
The bottom on the left-hand side, number 5.
That's it. It's so correct.
Anybody have a question about that one? Totally fine. Totally fine if your x plus 9 comes first. Check number 6 and 7. And then you got a problem with number 8. That's going to result in you not getting full credit. Look at what happened in number 8. I'm going to assume that almost everybody has this as their final answer. You've done it right. However, this has a 2 in it. So for something to be considered factored completely, neither of the factors can have a GCF. So for full credit, you have to see that and take a 2 out. Now that would not have happened if you take a 2 out from the start. So a common factor here is an indicator that there was a GCF to start. So look at the problem for 8. As the problem's given, could the whole thing have been divided by 2 as your first step? Yeah. That's the best way to do it, to take out the 2 first. But if you don't, you can take it at the end. You'll see it here in the factor. So if both numbers can divide by something, you need to take that out for full credit. So do it now. Take a 2 out. I'm gonna be walking around looking for it. See that?
I want to see that. I want to see that 7. Woke up at 1:30. I want to see that 2 o'clock. It's getting better. Obviously, you didn't hear. That's all you were saying. I didn't stop.
Alright, so staying with the same theme that I've just told you, look at number 9. What's the best step in number 9? I'm actually gonna make you guys do this over, I think. You got it. Is there a GCF the way it
I'll give you
begins?
power.
What can everything be divided by? I'm gonna take an X. All parts. There's too many X's in the problem. All parts of an X. So I'd like to rewrite it, taking one X and putting it out front. Do you follow that, Mark? Now I'm gonna group in here. And I take the X that I took and put out front. It's in my final answer cell. Now compare that to what you did. How does my answer in my box look different than yours, Aubrey? No. Which one of your factors had an extra X in it, the 3 or the 1? I guess it probably depends. Who's got this as a final answer? Okay. This one, you can still take an X out of. So I would rewrite it at X plus 3, X plus 1. And then it looks like what I did, but I took the X out in the beginning. Is there any more when you look at the original problem? It could have been divided by something before you started. Look at 10, 11, and 12. 10, is there a greatest common factor as it starts? What can it be divided by? And? 2 and y. 2 and y. Taking a 2y out first makes the problem even easier. Everybody do it again. Take a 2y out first. I'm not going to be able to give you full credit if you don't take your GCFs out. Divide everything by 2. Madeline, what do I get if I take a 2y out? What will be the result? Come on, you know how to do 4 divided by 2. And what will be left? X to the 3rd. And then 8 divided by 2 is 4. 6 divided by 2. Just dividing everything by 2. And then I'll group in here. see how the answer is a little more simple than what you did without taking the GCF? This is more simplified. What you might have on your paper, I'm curious to know. Do you have 4x squared y plus 6y?
Teachers, please for this interruption. At this time, please release seniors with last names starting M through Z to the jail.
If there are any seniors in the room, please go. It's a good
With last
experience.
names starting M through Z only to the jail. Thank you.
No. The college fair? So they have lots of brochures and things, and that's how you like. No, it's actually pretty cool. I guess they would be wearing it if you know for sure you're not going to college. If you're going to college, it's really kind of cool. I definitely did. Alright, what's the GCF in this one? You could take an X to start. And then the only difference will be one of your factors will have one less X in it. So my answer is 5x plus 3 and x plus 8. Who has that, but there's one extra x in one of their factors? Thumbs up if you got your numbers right. Oh, good. It's a good amount. It's a good amount. All right. Last one. Number 12. There's your answer. There was no GCF. Alec. On this one? 40 divided by 5. 24 divided by 3. Okay. So right now, you don't have to do it like I did in the beginning. Right now, take an X and put it on the outside. So listen to the words that describe these answers. This is factored, and this is factored completely. You gotta factor completely for full credit. I'm still going to do that. I'm about to do some pretty important notes. Just heads up.
Lazy. He's taking a picture. Okay. You gotta send me my homework. Sure. Do I don't?
Right now, you're going to take notes on kind of the longest, most complicated, most annoying type of factoring. It's actually two methods combined into one. But I mean, It's been going really well all day, so I think you guys are going to get it. So this is factoring when A doesn't equal 1. A being the number in front. So A doesn't equal 1, there's no GCF, so this only has 3 terms in it, 2x squared plus 5x plus 3. I think there's 5 steps you're going to write down. 5. Let's notice some things about the problem. First off, A equals 2, B equals 5, and C is 3. When A is greater than 1, factoring requires more steps. This method combines 2 types of factoring. I'm going to show you the steps, and then I'll do the problem with this. Feel free to take a picture. If you're more likely to look at a picture on your phone than look at the notes in your notebook, take a picture. So it's actually called the A times C method. So step 1, multiply A and C.
Equals.
Step 1, multiply A times C. Step 2, find factors of blank that add to blank. I'll tell you that in a minute. Step 3, rewrite the original problem using the numbers you picked. That's going to create a 4-term problem. When you're done, you can go ahead and do step 1. Multiply A and C, so that will be 2 times 3 is 6. Everybody know where I got the 2 and the 3 from? The number in the beginning, the constant at the end. So now we're finding factors of 6 that add to 5. The reason it's 5 is because you need to find factors of A times C that add to B. So this is like what we were doing before with factoring. Your little riddle. This is the same numbers that multiply to 6 and add to 5. What are they? 2 times 3 is 6, and 2 plus 3 is 5. So same skill we were using before. And now step 3 is where it gets weird. We're going to rewrite the problem, that original problem, but we're going to use the 2 and 3 that we just picked. So I'm going to keep 2x squared the same. Instead of 5, I'm going to do 2x plus 3x, and then I keep the last value the same. So 2x plus 3x combine to make 5x. So have I really changed the problem in any way? No. I'm just rewriting it in a way that's going to work for me. So you need to buy into the fact that this is the original problem. I've just split b up to make it useful. What's useful about it is now we can factor by grouping. So now we're going to do yesterday's skill with this problem. Now that you've created a problem with 4 terms, now you can do the grouping method, which is why yesterday's lesson was really important. So I'll take a GCF out here. 2x. Take it out here. I'm really happy that my parentheses match up. Now it's been factored. We combined the first method with the grouping method to factor when there's a number in front greater than 1. The last step is to solve those little factors. Do the little baby equations. So do x plus 1 equals 0, 2x plus 3 equals 0, and that's going to give you your actual x-intercepts. Who's got a question for the room? Might help everybody out. Yeah.
So like the 1x plus 1, you take the 1 to somewhere, and then 2x plus 3, you take the 3. Is that where you got this from?
I don't know. Did you write it like this? Did you write this?
Yeah, and then I did the separate.
Yeah, exactly. Yep. Let's try it again. It feels really long right now, but the more you do it, like the less you have to think about each step, and it actually flows pretty quickly. But this is the worst method. It's the longest method. I don't know. It's like required for this. Well, there's a lot of different quadratic equations. Every quadratic that is skinnier than the parent function has to be factored this way. So this is for every parabola that is skinnier than the x squared parabola, because there's a number in front, like this 2 in front means there's vertical stretch. So all of our vertical stretch parabolas have to be factored this way. Yes. Well, you already know how to graph that.
Yeah, but like,
Yeah, so like I really want to give you a quiz Friday where I give you this problem, I ask you to graph it, follow all the steps to graphing, and then I ask you to factor it. Follow all the steps of factoring, and then I'll ask you, like, do the solutions to the graph match the solutions to the factoring? Because your x-intercepts should be shown when you solve this. All right. Tricked me. All right, go ahead, A times C. What is it? Grace, what's 8 times C? 2 times 15 is 30. So step 2, I want to find factors of 30 that add to 13. This 13 is the B value. Yes. Okay, let's see. Multiply to 30. Add to 13. 10 plus 3. What are we going to do with the number? I'm going to put them back into the problem. So it's 2x squared. I'm not writing 13. Instead, I'm writing 10x and 3x, which is the same thing as 13x. And then I'm going to keep the 15 there. Pretty clever. I did not come up with this. Whoever did, pretty clever. People used to just guess and check before there was a method. All right, now we'll do the grouping. You have this great checkpoint where you can see that the parentheses match. You solve the factors. It's too quick. So what are the answers? Did anybody solve it yet? Madeline?
Yeah. -5 and then -3/2.
Yeah. All right, so you're going to do the back of the handout from yesterday. It's less problems. I think it looks like a lot, but I think it's only 5. The steps are over. So guys, work together on the first one because people are having a hard time showing up with the correct factors of what multiplies to 28 next to 29.
No.